This video is recorded to help students understand how to write a testing function. Suppose I want to write a function named or-even. It takes two inputs, x and y, both integers. This function returns true if x and y are both even, false otherwise. Now, before you actually write this function, you can write a testing function first. This testing function will return true if or-even function work correctly, false otherwise. So this testing function can be named, for example, called test or-even. This function takes no input. This function returns true if or-even function works correctly, false otherwise. Now, before we write this test or-even function, I actually can write a main function first. That's the beauty of top-down design. For example, my main function can be this: if test or-even. If test or-even is true, then we print out a message: or-even function works correctly. Else, print out a message: or-even function works incorrectly. Return 0. You see, before you write the function or-even, you can write the test or-even function first. Actually, before you write test or-even function, you can write a main function first. Now, let us write a test or-even function. Now, when I write this function, I need to know how many cases I need to test. There are infinity integers there. That means this function, you can have infinity input. It's not possible for you to test all. So we only test by cases. How many cases there? If you think about it, there are 4 cases. Case 1, x and y are both even. In this case, or-even function is supposed to return true. In this case, if or-even function returns false, that means the or-even function doesn't work correctly. So case 2, x is odd and y is even. In this case, or-even function is supposed to return false because not x, y are all evens. However, in this case, if or-even function return true, that means or-even function doesn't work correctly. Case 3, x is even and y is odd. In this case, or-even function is supposed to return false. If or-even function return true in this case, that means it doesn't work correctly. Then case 4, x and y are both odd. Okay. In this case, if or-even function return true, that means your or-even function doesn't work correctly. Now let us implement these 4 cases by using sample input. So for this example, you can say if or-even x, y are both even. Now x is 2, y is 4. Now in this case, if or-even return false, that means not true. That means not work correctly. So the test or-even function is supposed to return false. Else if or-even function, when the x is odd, y is even, in this case, or-even function is supposed to return false. However, if it returns true, that means your all even function doesn't work correctly. Now, case 3, else if all even, if x is even, y is odd, you give a test data to cover this case. If in this case all even function return true, that means it doesn't work correctly. Now, the last case, else if or even, they both odd. Now, in this case, if all even function return true, that means it doesn't work correctly. Now, if all those 4 cases, you use sample data to test each case. If all these 4 cases pass, you can convince yourself that all even function work correctly. So else return true. So we finished the test all even function. This test all even function did not test all integer data. Instead, it tested all the cases for the input. Now we can begin to write all even function. It is a simple implementation. Suppose we made a mistake. For example, if I made such a mistake, or even integer x, integer y, my mistake I say return x %2 equals 0, or y module 2 equals 0. Okay, suppose that's my implementation. Student like to make this mistake. Now, after I implement this, let us compile and run. Build successfully. The result say all even function works incorrectly. Why? If you look at this, x %2 equals 0. Equation say x is a multiple of 2. X is even. Or y %2 double equals 0, which means y is even. So it actually, this function implement as x is even or y is even. But the requirement is x and y are both even. So you use or is not correct. You cannot pass the test. So if I use and, then let me run the program again. This time the result say all even function works correctly. Now let us recall what we have done. The beauty of top-down design is this. Before I write this, right, all even function, I actually can write his test all even function. Then before that, I can write main function. Okay. Now, the test all even function, I don't need to test all the data. I just test all the cases. The 4 cases, x, y, are both even. X is odd, y is even, or x is even and y is odd, or x, y are both odd. Now, if the test pass all these 4 cases, then we can convince ourselves that all even function is true. This example similar to one of your label. If you still have questions, please email me.